Greetings, class. This is Mrs. McCoy, and this is our test review for test 3. So, as far as listing the steps for solving the equation by elimination, make sure you put it in some type of phrasing that makes the most sense to you. I kind of wrote out how it made the most sense to me in the 4 steps that we pretty standardly follow. Question 2 and 3 we'll come back to after we have the problem that has an infinite number of solutions and the one that has a no solution, so we can do that. The first 2 I want you to solve by elimination, so we're going to use our steps above. And let me scroll back up real quick. Our step said both equations have to be in standard form. So when I look at equation 1, it's not in standard form, so that would be my first step. I'm going to recopy it over here. And I'm going to add my 5y to both sides so that I have 3x plus 5y equal to 9. And now I can see that they are both in standard form. So we have our equation 1 in standard form and our equation 2 in standard form. Choose the variables we want to eliminate. So looking at this, I see that if I want to get rid of my x's, I'd have to multiply the yellow equation to make them both 9s, one positive, one negative. If I want to get rid of the y's, I'd have to multiply the yellow equation as well. So it looks like it's the same number of steps to do that in either case. Whoops, that wasn't what I wanted to do. There we go. So I'm going to decide to eliminate my x's. So that's my part of my step 1, choose to get rid of my x's. And that means I'm going to want to multiply both sides of this equation. I want it to turn into a negative 9 because I need opposites. I've already got a positive 9 in the green equation. So let's rewrite our equation 1. It's going to be negative 9x minus 15y equal to negative 27. Bring down my equation 2. It's positive 9x plus 15y equal to 25. Adding those 2 equations together, I've got negative 9x and positive 9x, which is 0, negative 15y and positive 15y, which is 0, negative 27 and positive 25, which is negative 2, and 0 does not equal negative 2. So the interpretation here is no solution. And I could also call that the empty set. Now, notice what those 2 answer choices are. It's not undefined. It's, we wouldn't say it's not real. You know, there are all these different phrases we use to mean different things, but they do have to have the appropriate meaning. All right, so the one that had no solution. Now, if I look at just in standard form, so I'm going to go ahead and write my 2 equations in standard form for this step. And my 9x plus 15y equal to 25. The way I could, there's 2 things I could do to check myself. One, I could write them both in slope-intercept form, and we know that no solution means when we're graphing that these are parallel lines. So when we are graphing, if we put it in slope-intercept form, they're going to have the same slope and different intercepts. So that's one way. This other way is one I think I've only gotten to mention briefly. If we look at the ratio of the x's, so 3 compared to 9 and 5 compared to 15, those are going to be equivalent fractions. And the ratio of the 9 of the c's, the constants, is going to be different. So let's use our calculator really quick and see what I'm talking about here. because we're going to simplify both those fractions and see if we get the same fraction, and then we're going to simplify the right side and see if that we don't. Okay, so fraction 3 over 9 simplifies to 1/3. Fraction 5 over 15 simplifies to 1/3, and fraction 9 over 25 does not simplify to 1/3. So, and this is only true that the ratio of the x's and the ratio of the y's is the same, and the ratio of the c's is different when they have no solution or when they're parallel, which means they're parallel. So that's one way. Those are the two ways that you can check. Now, I'm not going to ask for the check on the test for a no solution or an infinitely many solution. However, it is always a good idea to know how to do it. Okay, now, so we weren't able to go through all 4 steps for this for problem 4, but we will for problem 5. So my first step, decide what do I want to eliminate, my x's or my y's. And let's just take a minute to kind of look at it. If I wanted to eliminate my x's, I'd have to get them both to be the same number, which would be 3 and 7 both going to 21. I'd have to have one positive, one negative. So I'd have to multiply both equations to make that happen. Versus if I look at my my y's, looking at my y's, I can see that one's positive, one's negative, so that's good. One of them is a positive 1, the other negative 2. That means I only have to multiply one equation to make them opposites. So when that happens, then that tells me that it's going to be easiest because I only have to multiply one equation to make the elimination happen if I eliminate the y's. So in this case, we're going to choose the y's to eliminate, and we're going to multiply both sides by a -2. So -2 times +3 gives me -6x. -2 times y gives me -2y. And -2 times 14 times 7 gives me -14. Bring down my 7x. Oh, and I goofed that up. I didn't need to change my sign because I already had opposite signs. Sorry about that. So let's go in and fix that. So +2 times 3 is 6x, +2 times y is +2y, and +2 times 7 is +14. Bring down my 7x, my -2y, and my -1. 6 plus 7 gives me 13x. +2y, -2y add to 0. That's what I wanted to have happen. And 14 minus 1 is 13. Divide both sides by 13. And I have half of an answer. So when I have half of an answer, that tells me that this is going to be, my solution is going to be an ordered pair, that it's going to be an XY ordered pair, and that graphically these would be intersecting lines. And half my ordered pair says right now I have the x value of 1. And let's see what our next step says. Okay, we got one set opposites. Now we're going to substitute to find the other variable. So here was step 1. Here is step 2. Step 3 says I can use either equation, doesn't matter. I'm going to use the first one. So we have 3 times 1 plus y equals 7, or 3 plus y equals 7. So in order to move the entire term, we use its opposite. And that gives me y equal to 4. And then step 4 is to do my check. Now, whatever equation I used in step 3, I need to use the other equation in step 4. I can't check back into the same equation that I just did work in. Let me erase that and make that a little better. All right, so we have 7 times x minus 2 times y and a question mark, -1. So my x value was 1, my y value was 4. It's going to give me 7 minus 8, question whether that equals -1. Simplify all the way down to a single number on both sides. -1 does equal -1, so that is my check, and this is my solution. All right, let's go to page 2. So here we wanted to list our steps for substitution. And our first step is to choose equation 1 or 2. And I'm going to abbreviate equation EQ. And then choose the variable x or y that we want to solve for. Step 2, we're going to substitute into the other equation. And then at the end of step 2, we can tell if it is infinitely many solutions, no solutions, or the point of intersection. And if there are more solutions, if it is the point of intersection, then same thing we did on the other page, we're going to go back in and again substitute the value this time. Value found. So that we can find the other variable. And step 4 then, of course, is to check. So, substitution method. When I look at equation 1 and equation 2, I see in equation 1 that I have a coefficient of 1 on the y. So that says that's going to be my easiest choice. I'm going to subtract 3x from both sides. So y is equal to -3x plus 10, or 10 minus 3x, either way. Step 2, I can go to either equation. No, I'm sorry, I have to go to the other equation, not either. To the other equation, yep, that's what I said before. And that's what I wrote. Go to the other equation, so we have 7x minus 2 times the y value, which is -3x plus 10, set equal to 4. Distribute gives me 6x minus 20 equal to 4. 13x minus 20 equals 4. So I had to pause for a second because this wasn't working out, and so I needed to go back to look to figure out what I had done wrong. I have no idea how 11 turned into a 10, but it was obviously just enough to really throw off all of my work because it wasn't coming out to be the answer I expected. And okay, so this should have been an 11 and an 11, which means this would have been a 22. Well, not 222. So that when I add my 22 to both sides, then I have 13x is equal to 26, positive 26, and we're going to divide both sides by 13 to find out that x is 2. So again, we have half of our ordered pair, and we're then able to go back and find the other problem. I do want to comment right here, only because I had already worked this problem recently did I know I was supposed to not have a fraction answer. It is okay to get fraction answers in our problems. Being math land, we tend to write them so that they don't. And I think the only fractions and decimals I usually have on this test come from the word problems. So let's go back and find our y value. And let's see. Actually, I think it'd probably be easier to start in the other one, so we'll go ahead and do that. Step 3, we have 3 times 2 plus y equals 11, or 6 plus y equals 11, so that y is equal to 5. And then last step, step 4, 7 times 2 minus 2 times 5, and we want to know if that equals 4. That gives me 14 minus 10, or 4 equal to 4, so it checks out. Now that means this last one has to be my infinitely many solutions, so let's see if that happens to be. Again, notice that I happen to have one of them partially ready to go, so my equation 1, I'm almost ready to substitute. So if I take that 2x equal to 4y plus 12 and divide everything by 2, I have the equation 2y plus 6. There's my step 1. Step 2 says we're going to go now to the other equation and plug this in for x. So in place of x, we'll have parentheses 2y plus 6 minus 6y equals 18. Multiply. I can collect my like terms. Positive 6y and negative 6y are on the same side of the equal sign. They add to 0. And I have 18 equal 18, which is a true statement. And the interpretation of that is infinitely many solutions. Can also say all real numbers as a solution here. Oh, and then, so rather than going, well, I'll take it all the way back up there. So I'm going to take the second equation first, 3x minus 6y equal 18. And two x, so I never did, okay, 2x equals 4y plus 12. All right, so it needs to be in standard form. So we're going to subtract that 4y over. And then here, because they have an infinite number of solutions, all 3 ratios should be the same. So we have our x value over our x value, our y value over our y value, and our constant over our constant. So let's put them in fraction form and see. The first one, 2/3, is good. Oh, wrong calculator. Fraction key, -4 over -6. Well, that's not a 4. Let's fix that. And that gave me the 2/3 I had initially. And then let's check the 12 over 18. And that also gave me the 2/3. So since all three were equal to 2/3, then that tells me that they are in fact the same line, which is why they have an infinite number of solutions. And again, we could put both of these in slope-intercept form. If we do that, we'd have two identical equations, which also tells me infinitely many solutions. Okay, so moving on. And then we had question 9 and 10. So do pause, take time to read through this so that you understand what the question's asking before I start discussing the answers. Okay, so this question is asking us if we were given the solution of a system to describe what it looked like when we were graphing it. So whenever we got an ordered pair, then we know that that was going to be the point of intersection. So our point of intersection tells me that these are two lines that cross. So parallel is not my answer. Two lines cross at 2 points. The given point was one of the two locations. Lines can only cross each other at one place. Two lines cross at the given point, or they are the same line, which would have meant they had an infinite number of solutions. So the answer for that one was B. And when solving by either method, if the system is no solution, how does that relate to how the graph looks? So no solution, we know that there's not an answer on either line that they share in common, and that says they have to be parallel. And I do always read through all of the answers, even if I think I've got the right one, in case there's just a one-word variation that negates one of them and puts another one as the main answer. All right, that was our page 2. Let's go on. Page 3, we started our word problems, and we did talk about some of these in class. So I think what I'm trying to decide whether to go through and set them all up and then go back and work them. I guess I'll just work them one at a time. That way you can find the entire problem all at once. So first thing, of course, I want is the key. I want to know what your variables stand for. And we have hamburgers and we have corn dogs. So our hamburgers I'm going to call X, and my corn dogs I'm going to call Y. We go to the grill for lunch. You ordered 5 hamburgers. Oh, and so, sorry, I always forget to say this. This is the cost of the hamburgers and the cost of a corn dog, of one hamburger, one corn dog. So if I buy 5 hamburgers times the cost, and I buy 8 corn dogs times the cost, then that total bill was $41.50. Then my second one, very similar. Friend goes in, orders 3 hamburgers and 4 corn dogs, and their total bill was $22.90. Looking at these two, I can see that to me, my easiest choice would be to do the elimination method, because it would take one step to make the y's to be the same, and I would just have to multiply that bottom equation by -2 to make that so. So we have 5x plus 8y equal to 41.50, and then we bring down our other equation. Oh, sorry. Just getting ahead of myself there. So I brought down the first equation. Second equation, I need to multiply through by that -2. Ready to collect those like terms. I've got -1x, or just the opposite of x. 41.50 plus 45.80. Let's go ahead and punch those in. I don't know. 41 plus 5 plus, oops, all right, sorry about that. Got sidetracked completely there. 41.5 plus 45, oops, 0.8 gives me 8730. Nope, I got a mistake someplace. Forgot my negative sign right there. So positive 5x, negative 6x gives us x. Positive 8y, negative 8y add to 0. And 41.5 minus 45.8 simplifies to negative 4.3. Then we have to finish up. Divide both sides by negative 1 so that I get my x is equal to 4.3. Now we know that x was the cost of a hamburger. So over here we need a dollar sign and $4.30. My corn dog I'm going to have to substitute back in. So 5 times 4.3 plus 8y equal to 41.5. So 5 times 4.3 gave us 21.5. And subtract my 2150 from both sides. And don't lose decimals like I'm looking like I'm doing. So 8y is equal to 20. Divide both sides by 8. This is money, so I do need to convert. Oops. 20 divided by 8 gives me 2.5. And of course, since we're talking about the cost of the corn dog, gives me 2.5, $2.50. All right, I'm going to take a quick break here, so I'm going to put this on pause. And actually, I might let this one go ahead and process. Let's see. Yeah, I'm going to go ahead and stop this, let it process, and then I'll record the rest.